Good day and hello everyone! We are the Group 5. But before we start our video presentation, allow us first to introduce ourselves. My name is Ayan Jelay Api.
My name is Jamaria Bajes.
My name is Ladra Sonelia Peñalosa.
I am Reinhard Apostol.
I am Amberly Navarro Hadmat.
Today, we are going to discuss the topic under the subject or course of organic chemistry, aldehydes and ketones, which are actually play important roles in farming, food preservation, and even in the production of pesticides and herbicides. Let's start with the structure. Both aldehydes and ketones belong to a group of organic compounds called carbonyl compounds because they contain the carbonyl functional group. The difference is simple. In aldehydes, the carbonyl group is attached to at least one hydrogen atom. A common example is formaldehyde. In ketones, the carbonyl group is attached to two carbon atoms. A well-known keton is acetone. This small difference in structure actually makes a big difference in their reactivity and how they are used in agriculture. For example, aldehydes are generally more reactive than ketones because the carbonyl group in aldehyde is easier to attack by other molecules.
Next, let's talk about their properties. Both aldehydes and ketones have moderate boiling points, higher than alkynes but lower than alcohol. This is because the carbonyl group in polar is so their dipole-dipole interaction. They are also soluble in water if they are small molecules because the carbonyl oxygen can form hydrogen bond with water. Many aldehydes and ketones have strong odor. For example, valine, which gives vanilla. Its flavor is a hadine, and acetone, which is used as solvent, have a sharp smoke. In agriculture, these properties are very useful. For example, the solubility and polarity of ketones, acetones, are excellent solvent for pesticide and herbicide. Aldehydes like formaldehyde because of their reactivity can act as disinfectants or soil fumigant.
Now, let's move on the reactions. Aldehydes are easily oxidized into carboxylic acids. For example, formaldehyde can oxidize into formic acids. This is important in soil treatment where aldehydes can break down into less harmful substances. Ketones, on the other hand, are more resistant to oxidation, but they can undergo reactions like reduction, where they turn into alcohols. Both aldehydes and ketones can also take part in addition reactions with compounds like hydrazine or bisulfate, which makes them useful in analytical chemistry and creating agrochemicals. The reactivity of these compounds explains why they are widely used in producing pesticides, fertilizers, and preservatives in agriculture.
Now, here's the most important part. Application in agriculture. Aldehydes. Formaldehyde is used as soils, disinfectants, and fumigants to kill fungi, nematodes, and bacteria before planting. It is also used to preserve grains and seeds by preventing fungal growth. And another aldehyde is glutaraldehyde is used to disinfect agricultural fields and greenhouses. Ketones and acetones is widely used as a solvent to dissolve pesticides, herbicides, and fungicides, making them easier to spray and absorbed by plants. Some ketones are naturally found in plants and act as a defense chemicals or natural repellent agents space. This shows how these compounds, which may seem like just chemistry concepts, are actually deeply connected to farming and food.
Of course, while aldehydes and ketones are useful, they also come with benefits and also rest. So here are the example of benefits. Help in protecting crops from pests and diseases. Increase crop yield and food security. Used as disinfectants to ensure healthy soil and also seeds. And here the example of risk. Formaldehyde is toxic to humans and animals if not handled properly. Excessive use of acid-1-based pesticides may cause chemical runoff, which can harm aquatic life. Long-term exposure can affect soil health and biodiversity. That's why sustainable practices are important, using the right amount of chemicals, adopting integrated pest management, and exploring natural alternatives. Agriculture needs a balance between chemical use and environmental care.
To support our discussion, is study by Baker and Hall 2020 in the Journal of Agriculture and Food Chemistry highlighted the formaldehyde-based fumigant are effective in controlling soil-borne pathogen control, but they also emphasize that safety measures and controlled use are necessary to prevent environmental pollution. Another research studies on the toxicity of acetone, acrylates, and carbon dioxide are stored products in insects and weeds. Showed acetone that can kill stored products in insects effectively while having negligible effects seen viability under specific exposure levels. Science alert these studies suggest that while acetone has potential as a fumigant or pest control vapor, more field-based research will be needed to confirm its effectiveness and safety in controlling soil-borne pathogens in agriculture soils. This shows the importance of scientific research in guiding the safety and sustainable use of aldehydes and ketones in agriculture.
In conclusion, aldehydes and ketones are not just chemical names we hear in class. They are compounds with unique structures, properties, and reactions that makes them useful in agriculture. From soil treatment and pest control to seed preservation and solvent use, they play a direct role in food production. But with these benefits also come responsibilities. Farmers and agricultural workers must use them wisely, following safety guidelines